Okay, now we're going to look at sketching inequalities. You'll have done some of this at GCSE. However, at A level, you're expected to extend what you know by sketching quadratic inequalities. So, a little bit of terminology to start off with. X is greater than 2 is a strict inequality. We call it strict because x cannot equal 2. It means x is strictly bigger than 2. And if we want to draw a strict inequality graphically, we would represent it with a dashed line. So on our set of axes, we mark x equals 2, we draw a vertical line that's dotted, and I'm going to shade the side that I don't want. Sometimes you'll shade the bit that you do want. The reason we won't do that very often in this lesson is that we'll be drawing more than one inequality. And if you're drawing them by hand, and you always shade the bit you do want, you end up having to do a lot of rubbing out when you end up eliminating regions from your graph. But it is worth being aware that it's perfectly acceptable to shade the region that you do want. And in fact, as I'll show you later, that's the way your calculator can do it. Next up, we've got non-strict inequalities. So y is greater than or equal to 3 is a non-strict inequality. And to represent those graphically, we use a solid line. So here's our set of axes. We mark on the point y equals 3. We draw a horizontal solid line through it, and we want greater than 3, so we shade the side underneath the line. And there we have a sketch of y is greater than or equal to 3. So let's have a look at an example then. In this example, we're not really going any further than GCSE. It's a little bit of a recap for you, just to get back into the flow of what you need to do. In example 1, we need to illustrate a region defined by 3 inequalities. First of all, we've got x is bigger than 5. So we mark 5 on the x-axis, we draw a dashed vertical line, and we shade the side we don't want. As we want x is bigger than 5, we shade to the left. Next up is y is bigger than or equal to 10. We mark 10 on the y-axis, we draw a horizontal line. This time it will be solid because it's greater than or equal to. And we shade the side we don't want. We want y is bigger than 10, so we shade underneath the line. Next, we've got 2x plus 3y is less than or equal to 60. If you can draw this line without any working out, great. I'm going to do a little bit of working out to show you how I would draw this line. So 2x plus 3y equals 60 is the line that I'm going to draw to start with. I would say when x equals 0, that means this bit will disappear, 3y equals 60, y equals 20. And when y equals 0, this bit will disappear, and we would get 2x is 60, which gives x equals 30. That means we can mark 0, 20 on the axis, and 30, 0, and draw a line in between them. It's not necessarily as obvious which side of the line to shade here, so whenever you're unsure, here's a method you can use to find out which side to shade. First of all, choose a point on one side of the line. It doesn't matter where, as long as you know it's on one side. So I'm going to choose the point 1, 1. Once you've chosen a point, sub it into your inequality and see if it fits. So I've got the inequality 2x plus 3y is less than or equal to 60. Using the point 1, 1, we get 2 lots of 1 plus 3 lots of 1, which equals 5, which is less than 60. So this point does fit the inequality. If it fits the inequality, it means it's on the side of the line that you want to include, so we shade the other side of the line. So we're going to shade above the line. Notice the point doesn't have to be in the final region, it just has to be on the correct side of the line you're currently working with. Now there was nothing special about choosing the point 1, 1, it's just 1, 1 is a nice easy point to substitute into an equation. 0, 0 is often a good point as well. Finally, don't forget to label the required region R. Right, time for you to have a go at one for yourself. In this one, you've got a similar kind of idea, but with 4 lines. Once you've had a go, come back and check your solution against mine. Right, here's my solution then. So we've got the line x is less than 4 to start off with. Mark 4 on the x-axis, draw a vertical line that's dashed, and we want x is less than 4, so shade the bit that's bigger than 4. Next up, y is less than or equal to 8. Mark 8 on the y-axis, solid line across, and we want less than or equal to 8, so shade the bit above the line. Next up, you've got y is 2x plus 3. We have a y-intercept of 3, we can mark that on the axis. If we think about what happens when y equals 0, you would end up with x is minus 3 over 2. Draw a line through those 2 points. And we want when y is less than 2x plus 3, so we want underneath the line. If you're not confident with that, you could have checked a point and you'd have found that that was true. Finally, we've got 5x plus 3y equals 15. If we set x equal to 0, we get y equals 5. And if we set y equal to 0, we get x is 3. Drawing a line through those 2 points gives us that. Next up, we choose a point that's on one side of the region. I'm going to choose 1, 1 again. And if I substitute 1, 1 into that equation, that would give me 8 is bigger than 15, which is clearly not true, which means I want the other side of the region. So I shade this side. Finally, label your region R.